So I'm going to start by writing my perfect squares at the top. So we have them. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8. You guys shouldn't have to ask me for the perfect squares. You should be able to just do 1 times 1, 2 times 2, 3 times 3, and so on. Now, every year the question comes up, well, I got a different answer. What did I do wrong? Here's the most common thing that students will do. What they might do is they might notice that 32 is the same as 8 times 4, for example. So they'll go square root of 4 times the square root of 8. Great, this is a good start. So we end up with 2 square root 8. And they think, hey, I'm done. Problem. 8 can be reduced further. So what actually happens is if you use the method that we talked about, where you take 32 and you cut it in half and you get 16, this 16 is where you start in our list. So you see that 16 is actually in the list, which is perfect. That means we can switch this into the square root of 16 times 2. Which is square root 16, square root 2, which is 4 square root 2. This is where students say, wait, Nina, I got something different. I got this. And I say, no, guys, it's this. Here's the problem. It's not really a problem, but it just makes more work. You need to further reduce this 8 because the 8 can be split into 4 times 2. So then you end up going 2 square root 4 square root 2. And you get 2 times 2 times the square root of 2, which is 4 square root 2. Now, that's pretty annoying, even to me. It's a lot of extra work. That's why it's important to start by dividing by 2 to see where your biggest or best shot is. This is going to be your biggest option. So again, start by dividing by 2. It seems tedious, but it's going to save you time compared to doing all of these steps in red. So let's do the appropriate method here in purple. So we're going to do 72 divided by 2 to start off, which is 36. This will tell us where to start in the list. So go find 36 up here, and look at that, it's in the list. Awesome. So we end up switching this to the square root of 36 times 2. They can break up into 36 and root 2, which is 6 square root 2. If you guys ever want to know if you're right or wrong, literally type into your calculator, square root 72, hit enter. Then type in 6 square root 2, hit enter. You'll get some janky decimal, but you should get the same janky decimal. If you do, you're right. If you don't, you're wrong. At least you know you're wrong. All right, let's try this one. 147 divided by 2 is, gotta calculate that. 73.5. That is not in our list. $73.5 would be somewhere here. So we're going to start testing 64. So if we do 147 divided by 64, it's garbage. It's like 2.2 something. That's garbage. So we do 147 divided by 49. We get 3. Because that's a nice pretty number right there, this integer is pretty, we're going to use this to rewrite it. So we're going to change that into square root 49 times 3, which is square root 49, square root 3. And if you simplify, you get 7 times the square root of 3. Again, type in this in your calculator. Then type in this in your calculator and see if you get the same thing. I'd like you guys to try 300, the square root of 300. Pause the video and give that a shot, see what you get. I ran out of room up top here. After 121, we'd have 144 and 169. So we need to test 144 first because 150 is in between there. So if we do 300 divided by 144, it comes out bad. It's a decimal. If you do 300 divided by 121, it's also a decimal. It's like 2.5, no good. If you do 300 divided by 100, we get 3. So this is a good one for us. We can change this to the square root of 100 times 3, which is root 100 root 3. So we get 10 square root 3, 10 times the square root of 3. I'll save this for the next video, so hang tight.